I'm back, and we're still factoring. And we're going to make it more difficult, because that's what we want to do. Let's look at this problem here. And how is this polynomial different than the other polynomials we've factored? First, we have a cube. We have not done a cubed polynomial yet. But we also notice we have 4 terms. And we have not done a 4-term polynomial. So how are we going to factor this? The first thing we're going to do is we're actually going to think of this as 2 separate problems. And when I look at 35x cubed minus 49x squared, if it was its own problem, I should see that I have a greatest common factor here. The greatest common factor of 35 and 49. What number goes into both 35 and 49? That's 7. And what about the greatest common factor of x cubed and x squared? X squared. What does that leave over? 35x cubed divided by 7x squared is 5x. Negative 49x squared divided by 7x squared is negative 7. Now let's do the right side. Greatest common factor of 20x and negative 28. How about a 4? And because even though we don't have a sign, let's call it a positive 4, because 4 is positive. 20x divided by 4, 5x. Negative 28 divided by 4, negative 7. And I'm pretty sure you see it, but let me tell you that it has to happen that you get the same thing in the parentheses. If not, you have a problem and you need to go back and do your GCFs again. All right, so that helps a little bit, but what does that really mean in terms of a final answer? And for a final answer, let's think about this. If I told you to take 7x and add it to 4x, how would you do that? Well, you would take the 7 and the 4 and add them to get 11, and you would just keep the x variable the same. We're going to apply this principle to this problem. We're going to add our coefficients, our 7x squared this time, and our 4, which is just 7x squared plus 4, and we're going to keep our parentheses the same. And now we have factored a 4-term polynomial into 2 binomials being multiplied. 7x squared plus 4, 5x minus 7. And since you've done multiplication in the previous lessons, you could multiply this out and make sure that this is the right answer. Let's try another one. 28x cubed, 21x squared, 32x, and 24. A 4-term polynomial, an x cubed. So let's go ahead and divide it into 2 problems. GCF of the left side. Greatest common factor of 28 and 21 is 7, and of x cubed and x squared is x squared. That leaves 4x plus 3. And using the little tip I gave you on the previous problem, we're really going to try to get in our head, remember we want this to be 4x plus 3 for this to work. So our GCF, 32x plus 8, or plus 24, is a positive 8. And hey, look, that does leave me with 4x plus 3. And again, this must happen. Parentheses must be the same. Now, in order to combine, we add our coefficients, 7x squared and 8. And our parentheses stay the same. 7x squared plus 8, 4x plus 3. That's our answer. Last one like this. 20x cubed plus 12x squared minus 35x minus 21. Split it in half and do our greatest common factor of each side. On this side, 4x squared. That leaves me with 5x plus 3. On the right side, greatest common factor is a negative 7. And that leaves me with 5x plus 3. My parentheses are the same. Excellent. Add my coefficients. 4x squared minus 7. Parentheses stay the same. And there you have it. Just like that, we were able to factor a 4-term polynomial. Here's a different type of problem that we have to be able to do. X to the 4th plus x squared minus 2. And we need to factor that. Well, we have an x to the 4th and an x squared. Those are different exponents that we're used to seeing. And we only have 3 terms, so there's no breaking it in half like we did earlier. So what are we going to do? And the first thing we're going to do is a little bit of substitution. We're used to just seeing a letter here, a variable with no exponent. So let's say, man, I really wish it could just be something like a y. That would make it look easier. So really what I'm saying is x squared equals y. Instead of saying x squared, I'm just going to change it to a y, and I can do that. So if x squared equals y, x to the 4th equals, if x squared equals y, x to the 4th equals y squared. So I can change this to y squared. And if I copy the rest of the problem down, that looks very much like problems we've been doing earlier. And it is. So let's factor. There's the 1 out in front. 1 times negative 2 is negative 2. How do you multiply the 2? 1 times 2. Negative tells me my signs are different. Positive tells me my right column is the positive, and this equals 1, so perfect. So if we factored, we would get y, because we're talking about y's right now, minus 1, and y plus 2, straight from there to there. Okay, so we have y's, but that's not even what our problem started with. Our problem started with x's. Well, we look back to here, and we see, oh, y equals x squared. So we could really change it to x squared minus 1 and x squared plus 2, because y equals x squared. And that makes a lot more sense. If my problem started with x's, my answer should probably have x's. If we FOILed this, we would get that polynomial. But, and this is really tricky, and this is where you're probably very anxious to say, we're done, but we're not. We have to make sure that these parentheses don't factor again. And does either one of these parentheses factor again? Actually, the left one does. This is a difference of squares. This factors to x plus 1, x minus 1. This does not factor, so we keep it the same. X plus 1, x minus 1, x squared plus 2 is our final answer. So we substitute to make it look like a polynomial that we're used to. We factor that polynomial, we resubstitute, and then we make sure that our answer doesn't factor a second time. If we were going to use words, which I encourage in your notes, we're going to substitute, we're going to factor, we're going to, I'll call it reverse substitute, and then we're going to check if we can factor again. Let's do a couple more of these. X to the fourth plus 8x squared minus 9. Again, a trinomial, 3 terms. And this x to the square, x squared, is what is throwing us off. And we should notice that right away. Again, it would be so much better if it was a y instead of an x squared. So let's make that substitution and say x squared equals y. So x squared equals y, x to the fourth equals y squared. The rest of my polynomial stays the same. The 1 times the negative 9, ways to multiply to 9. Negative tells me my signs are different. Positive tells me my right column is the positive column. This must be the negative column, and that gives me my 8. So now I can factor, and remember we're going to use y's because we're talking about y's right now. Now that we've factored, let's resubstitute or reverse substitute. X squared minus 1, x squared plus 9. Don't stop too soon. Can we factor there? We can factor x squared minus 1 to x plus 1, x minus 1. And this is our final answer. Another problem, x to the 6th minus 8x cubed plus 15. Exponents are even wackier now. We have a 6 and a 3. Don't worry, follow the same steps. We would much prefer this to just be a y. So let's substitute and say, well, I'm just going to say that x cubed equals y. Well, if that's true, then what is x to the 6th? Well, that's y squared. Factor like you used to. 1 times 15, 15. Ways to get 15, 1 and 15, 3 and 5. Positive 15 tells me signs are the same. What same sign? Negative. Which row equals, adds to negative 8? The bottom row. Put in our y's at first, and now resubstitute x cubed minus 3, x cubed minus 5. Do these factor again? We haven't talked about difference of cubes, so no. These don't factor again. I'll just give you that clue, but this is how you would get to this point. Once we talk about difference of cubes, then you would have to check this, but for right now, let's just know that this is where we need to be. And that's all for this lesson on factoring. We've done 4-term polynomials, and we've done trinomials with exponents higher than x squared is our leading term. Hopefully you understand it, and I'll see you next time.